Good afternoon, everyone. My name is David Boyer. I'm a regional sales manager for Hendrix Aerial Cable Systems. I will be your host for today's webinar, Hendrix Aerial Spacer Cable 101. This is the first in a series of 4 webinars we're conducting between now and the end of June. This session will review the mechanical and technical aspects of spacer cable system and how it relates to specific applications. We'll also point out the system's advantages when traditional overhead or underground construction isn't the best option. As to our format today, we'll begin with a 40 to 45 minute PowerPoint presentation, and we'll follow that with another 45 minutes of Q&A for a total of 90 minutes. Most of you are already familiar with the Q&A tab appearing at the bottom of your screen. During the presentation, use this tab to submit your questions. I'll be screening the questions as they come in, and will relay some of the questions to our presenter during the presentation. Then at the end, we'll address all other questions during the Q&A segment. So now that I've covered the format formalities, I would like to introduce today's presenter, Mr. Ted Gardner. Ted has worked in the electric utility industry for 25 years. He's a graduate from Western Michigan University with a degree in electrical engineering. Ted started his career as a distribution engineer for American Electric Power and has spent most of his career in utility equipment manufacturing, working both in sales and marketing. He's been with Hendrix Aerial Cable Systems for 10 years, where his roles have included direct sales engineer, regional sales manager, and currently as the technical manager for overhead solutions. He is from Portage, Michigan, where he lives with his wife and 2 sons. Without further ado, Ted, the floor is yours.
Okay, thanks, Dave. Good afternoon, everyone, or morning, maybe to some of our folks out west. Like Dave said, we're going to kind of start going through, some of the basics of a spacer cable system, and then we'll spend a lot more time going through the various applications where spacer cable will really provide a lot of benefits to utility customers as well as commercial and industrial applications. Like Dave said, if you've got questions that come up along the way, please use the Q&A or the chat screen. He'll be keeping an eye on that, and if it makes sense, he'll kind of add that, stop me at a particular point, and we can answer that. Otherwise, we'll have plenty of time left over at the end to answer as many questions as we can get. So Bill Hendrix started the company in 1951. Our first spacer cable systems were put up in 1952 near Milford, New Hampshire. This photo is taken on the original site where the factory's been since the early 1950s. In fact, some of the original aerial spacer cable is still installed, relatively close to the factory there. You can tell by the photo that the factory's been added onto a number of times. There may be a few people that have been able to tour that facility. Milford, New Hampshire is located about an hour or so north of Boston, Massachusetts. We do all of our own drawing and stranding in this factory. If you were there probably 8 or 10 years ago, you would have seen a lot of our plastics molded product machines there. We've since moved those to another facility in Amherst, New Hampshire, which is only about 7 or 8 miles away from where this is at. So I'd encourage anybody that's in that area to stop by the factory for a tour. The nice thing is you can hit both of those locations relatively easy. Nowadays, we have aerial spacer cable in all 50 states. And I think we're actually up on over 70 different countries now and on all 7 continents. Really, the point here is this is not a new product. There may be a number of customers that are online here that have used it for a number of years. And this may be a relatively new solution to a lot of people as well. But we've got a lot of experience, application experience in the field of over 60 years. And And yeah, we've been very successful. It's been a reliable product. So we're going to get pretty basic here. What is a spacer cable system? It's a messenger-supported 3-layer cable system in a close triangular configuration. You'll hear me refer to it a lot as a system, and that's really kind of the way we look at it. It's not individual, standardized components. We look at it as an engineered system, from the messenger to the spacers to the conductor itself, right down to the brackets, how they interact from both an electrical and a mechanical perspective. We're the only manufacturer that makes the entire system, and we take a lot of pride in that. There's been a number of manufacturers over the years that have made either the spacers themselves or the insulators or just the cable, but we have a good understanding of how all of these different components interact with each other. So we try to maintain it as an engineered system. So that's how we refer to it. So to break it down into the individual components, I always like to start with the conductor itself. We start with an all aluminum compact conductor. Where the compact becomes important is when you have to splice it, and you want to make sure that you're using splices that are designed for compact conductor, not regular round, what you see it with your normal ACSR. We show here a 3-layer cable system. Historically, there have been single-layer spacer cables as well as 2-layer. Hendrix has always made 2 or 3-layer systems. The only difference between those two is that initial layer of semiconducting polyethylene. In years past, we'd have said, if there's an incident or an opportunity for tree contact, we recommend you go with the 3-layer cable. But if it's just multiple circuits or long spans or something like that where trees aren't going to interact with it, the 2-layer should be fine. But now, really, because our system has become, our manufacturing process has become so efficient, and we understand that it's just a much, much better product from an electrical perspective, for the most part, we recommend you go with 3-layer cable. This says we go down to number 2 conductor. We really only make down to 1 for the most part. We can make number 2, but there's just not much of a demand for that in our market. So we can make it, but there's usually comes along with that, pretty high minimum order quantities, and 1 is a much more popular size. So that tends to be a little bit lower cost. If you look through our catalog literature, most of our standard sizes go up to 795 kc mil conductor, but we can go all the way up to 1431. The limiting factor is really we've got a 2-inch maximum outer diameter that we can manufacture. So obviously, as you go up in voltage with the cable, the thickness of the covering goes up, so the maximum size that we can manufacture will actually go down. But we can make all the way up to 1431 kc mil conductor. One thing you'll notice that's not listed on here, and I probably won't refer to it, I'll refer to it as covered conductor, not insulated conductor. Now, the covering that we have has insulative properties, but this is not considered fully insulated cable. It's not shielded. It's not insulated. It's what they call a dielectric covering. So what this does is it allows us to put it relatively close together. We can reduce our phase to phase and our phase to ground spacing, but there still is a minimum spacing that we must maintain. So another place where it comes into play is from an operational perspective. Linemen are still required to treat this just as they do bare wire because it's not fully insulated cable. We start at 15 kV, go all the way up to, 69 kV, but we're actually getting ready to launch a 115 kV product, and I'll talk a little bit about that here in a minute. Uh, you can get the covering in black or gray. From an operational or a technical perspective, there isn't much difference between the two colors. It's really a personal preference. There's an outer jacket made of high density polyethylene, and then there's an intermediate layer of natural low density polyethylene. It's a little bit softer, makes the cable a little bit easier to strip the covering off if you have to make a tap. We get a lot of questions about tree wire versus spacer cable. And I won't spend a ton of time on this. We actually have a webinar coming up where one of our other folks will go into this difference in a lot more detail. But just to give you kind of the short version of that, we manufacture both tree wire and spacer cable. What we call tree wire is covered ACSR or covered aluminum alloy conductor. As I said, spacer cable is typically all aluminum compact conductor. Aside from that, that's really the only difference. The thickness of the covering, the number of layers, the materials that we use are identical. So the only difference is the core conductor. Now, obviously, you're not using the support of the messenger or the spacers to support the weight of the cable, so that you can string it from pole to pole using more of your standard construction practices. The downside to that is if you need to dead end it or use a dead end shoe or a grip, you can't do that over top of the covering. So you have to strip the covering off anytime you're going to dead end it. So that makes it, not necessarily a fully covered system. We do go all the way up to 69 kV on this product as well. From a tree trimming perspective, a clearance perspective, like I said, a lot of utilities will still maintain the same clearance between the conductor and the vegetation. But when you put all of the three phases in a relatively tight space, as you would with spacer cable, that significantly reduces the amount of trees that you have to keep trimmed back. The other thing is overhanging trees. Because you have the protection of the messenger on spacer cable versus tree wire, you don't have to worry about removing all the trees on top of a spacer cable system. With tree wire, it's really protecting you mainly against momentary or brush contact. So if any significant tree or tree limb falls on it, it can still bring the conductor down to the ground, just as it would with bare wire. The messenger is the kind of the mechanical backbone of a spacer cable system. If you look at our construction standards, that's really the only thing that's kind of bolted to the pole, if you will. So I always tell guys, from an engineering perspective, we really look at spacer cable as a one wire system. All the mechanical characteristics of the messenger are what we focus on. The phase conductors and the spacers are really just added distributed weight to the messenger. So we use, in most cases, aluminum clad steel. This serves a couple of different purposes. It's obviously high strength. We've got rated breaking strengths from 12,000 up to over 60,000 pounds. But also that layer of aluminum on it protects it from any corrosion. So, it's a covered system. It gets used a lot in, corrosive environments, seacoast applications, commercial and industrial type applications as well. So we want to make sure that steel is protected. The other thing that it does is our recommendation is to ground it at the most every 500 feet, although most utility companies will ground it at every pole. So since it's on top of the system and everything's hanging below it, if it's grounded properly, it really kind of works just like a shield wire like you'd have with transmission. So it serves multiple purposes. It also gives us enough conductivity typically that it can be used as the system neutral. So it's going to serve as, the main protection member for falling trees and branches. It's the neutral wire, and it kind of works as a system, a shield wire as well. The spacers themselves, since we're using all aluminum compact conductor, there's not a lot of mechanical strength there. So you can't pull it to any great deal of tension. So the phase conductors are really just kind of sitting slack, and the spacers are spread out about 30 feet from one another. So the phases aren't under any tension, and these are supporting the weight. Now, the shape of them, there was actually, quite a bit of thought put into it. If you look at the triangular configuration between the three phases, that reduces the mean distance between all the phases, and it actually will help us with voltage drop. You've got a 15 kV system, but the phases are much closer together, so it'll actually reduce the reactance between the phases. So you'll see about a 20% improvement in voltage drop. Traditionally, obviously, we start at 15 kV. Our phase-to-phase spacing at 15 kV is about 8.5 inches. The next size that's going to be used for 25 to 46 kV, the phase-to-phase spacing is about 11.5 inches. So it's still a pretty tight configuration, but it's still, it's not very far apart. We also have a GO95 version where the phase-to-phase spacing is about 18 inches. This is a standard that they use out on the West Coast just to get more phase-to-phase spacing, even though it's a covered conductor. We also will even have clients that will use this even in the Midwest at pole locations just to spread the phases out a little bit more. So that it makes it a little bit easier to work on, especially if you've got a tap location for a transformer bank or a three-phase riser or something like that. The key thing about the spacers themselves is actually the material that they're made from. We mold these in-house from the same exact high-density polyethylene that we put on the covering of the conductor. So we know that from an electrical perspective, they're completely compatible. So that becomes an important piece, especially, historically, as other manufacturers have come in and made spacers from, different materials that have different electrical characteristics. Our experience has always been we want to use the same exact polyethylene that's on the covering of the conductor. We also make a single phase version. That's our RTL 20V. The 20V stands for 20 kV line to ground. So that's good all the way up to 35 kV system voltages. So we really only have one size for those. And something that we don't show on here, we also make a DM version of all of our spacers. It's got a bolted connection for the connection to the messenger. So we use those in high wind areas and any areas where there's a significant slope or change in elevation. Excuse me. Okay, sorry about that. Like I said, we go all the way up to 69 kV. At 69 kV, we really only make a DM version. This is our newly designed 69 kV. So if some of you have some experience with our 69 kV product, this may look a little bit different. And since the whole spacer is manufactured from the polyethylene, the plastic, obviously, the bigger you make that support member, the more flexible it gets. So we've had a couple of cases where we've wanted more, mechanical strength to it. So we've redesigned the center of this spacer with a little more mechanical strength than the design that we've had in the past. So this is a relatively new design. but face-to-face spacing here is about 30 inches. So it's a pretty good size spacer. You can kind of see the scale of the picture on the right, but it's still, at 69 kV, it's a very, compact type of construction. Like I mentioned, we're getting ready to launch our 115 kV version of aerial spacer cable. And putting more covering on the conductor, wasn't a monumental task for us to undertake. But like I said, as you get a little bit larger on the spacer themselves, that's where the challenge becomes. So our engineers kind of had to come up with a brand new concept for the spacer itself. So the one on the right is what the 115 spacer is going to be like. You've got that cast aluminum, kind of arcing member across the top, and then what kind of looks like suspension insulators that suspend the cable down below. Our molded products group a few years ago developed technology that allowed us to overmold a fiberglass ride with our same polyethylene that we use on the spacers and the covering of the conductor. And that technology really enabled us to come up with a design like this. So you still have, consistent phase-to-phase spacing, but, as you spread it out, it becomes, mechanically a lot stronger between the phases. High density versus polyethylene or porcelain insulators. Obviously, early when we came out with covered conductor and spacer cable specifically, clients were all still using porcelain insulators. What we started to notice was a breakdown in the covering, especially at corner structures where the cable comes in contact with the spacer cable. It's more of an issue at 25 and 35 kV. And a big reason for that, or the main reason for that, is the dielectric constant of all these different materials is different. And as if you're using, different materials, you start to see a breakdown of those materials. So in the early 1960s, we came out with our own tie-top insulator, and we manufactured it from the same polyethylene that we put on the covering of the conductor. In the mid 70s or so, we kind of took that a step further and developed what we call our vice top insulator. So you can see that in the picture here on the bottom. It comes with a mechanical jaw built right into it, so you don't need any preform grips or covered tie wire. We still obviously manufacture the standard tie top, but we probably sell more of that for bare wire than we do covered conductor, but it works just as well for both. The one thing that I always try to point out is, even if you are using the tie top insulator with covered conductor, we recommend use covered tie wire, because again, you don't want any bare aluminum, you don't want any steel grips or anything touching the covering of the conductor, because that'll cause the breakdown in the covering, especially at the higher voltages. The hardware and brackets, these pictures are taken out of our standard construction drawings. So this just kind of gives you a few different examples of the different construction types. This is just a small sample. The left, this is what we call our light angle. So this is good from 7 degrees all the way up to 60. You can see we could do a running corner with the messenger and the phase conductors. The center picture is our standard dead end bracket. It's still a relatively tight configuration if that's desired. But you can also take the phases, and instead of using that dead end bracket, still use a cross arm and just spread the phases out as you would a standard bare wire dead end. But you'll notice that the grips that we use are designed to go right over top of the covering. Our goal from a design perspective is to keep as much of the covering intact as possible. So we've got specially designed grips that are actually coated so that there isn't, so the electrical interaction between the grips themselves and the surface of the cable are more compatible. So that you can keep that covering on and you don't get any excess leakage current that'll cause a breakdown in the covering. Because the phases aren't under any great deal of tension, we can even roll those to vertical, and that's kind of what we show in the right-hand picture. We've got the standard tangent, but we've rolled it to vertical, and then there's a three-phase tap that comes off vertical as well. We can even turn angles like an outside angle. We've got this, what most of us call an E bracket on the left that'll actually move the messenger out and away from the pole so that you can turn the angle on the outside. Obviously, guying becomes more of a challenge, so usually going to a stub pole or a span guy is the way to go on that. Our standard tangent configuration is shown there in the middle. One thing I didn't mention, and I always try to point out, what you'll notice with most of these constructions standards is we're only using one side of the pole. So one of the bigger, more popular applications for spacer cable is multiple circuit installations. And I've got some pictures of that coming up. It really makes it very applicable and beneficial to use that. The through bolts that are holding that tangent bracket on, you can actually just put another tangent bracket on the back side of those poles or on the back side of those bolts, and you've doubled the capacity of your pole without having to go with a taller pole. So obviously you're dealing with a lot more weight. So it has to be a lower class pole, a beefier pole, but that still tends to be a little more cost effective than going with a pole that's 5 or 10 feet taller. The picture on the right is what we call our heavy angle. This is good from 60 all the way up to 90-degree angles. You'll notice that the phase conductors are still, it's a running corner for our phases. And the reason we can do that is because there's not any tension on the phases themselves. Now, we will double up on the pins and insulators just to soften that radius a little bit as we're going around a corner. The key difference is you'll notice that the messenger is double dead-ended. So anything over 60 degrees, and we want to double dead-end the messenger. NESC rule 234-1, we always try to point this out. This is really one of the big advantages in more of a municipal environment. Horizontal clearance to, man-made structures like buildings, billboards, different, radio and TV antennas. You can reduce the required spacing by the NESC by 2 feet. It doesn't seem like a lot, but when you take all three phases and you put them in a window that's only about 12 inches wide, and you only need 5.5 feet on either side of it, you can get, spacer cable in a pretty, tight space and still meet the required, NESC code. So it becomes a pretty popular alternative to, burying the conductor underground or rerouting it out and around and out of alleyways. So we show, clearances to street signs or street lights on the right here, alleyway construction where you've got houses in a pretty tight alleyway. Probably, obviously, the most common application for spacer cable is in heavily treed areas. So again, you can not only reduce the clearance required between the vegetation and the spacer cable, but it's also a very robust protected system from the covering, in addition to the messenger and the tree limbs and that falling on it. Like I said, alleyway construction is utilities are starting to take a look at, how do we upgrade our system How do we improve the reliability in the most cost-effective way possible? Now, we understand that, ideally, you would bury all the conductor, but that's just not practical in a lot of applications. So converting it to spacer cable or covered conductor is always a good place to actually save you money. In this case, you got a couple of different options. You can bury it all underground, but that gets pretty expensive pretty quick from the material cost as well as the construction and labor costs. The only really other option to meet code is to get it out of the alleyway and reroute it. So this allows you to install spacer cable, keep it in the alleyway, and still meet the code. Long spans, another common application. And the nice thing about spacer cable is, typically with bare wire construction, you really have to size the conductor for the tension and the span that you need, especially if you're doing a highway crossing or a river crossing or something like that. Like I said, all we're really worried about, all we're concerned with when it comes to span length is the size of the messenger. So I don't have to worry about what size conductor I'm using. I just have to adjust the size of the messenger. So we can really, run spans, I don't want to say as far as we want, but, we can, meet whatever, requirements there are, and we don't have to worry about increasing the size of the actual conductor. So the longest one we've done is 1,600 feet. This is at a little co-op utility in Northwest Indiana. This project originally, they had to upgrade the conductor size. There were 3 separate structures, one for each phase. And they originally looked at going with, subsea armored cable underneath this lake. It kind of looks a little bit like a river, but it's actually a lake. And that price tag was going to be about $1 million. So they looked at just rerouting the conductor and kind of skirt the edge of the lake. And that was, I want to say, it was going to be, 7 or 8 miles, and was still going to run them, $700,000-800,000. So they did this 1,600 foot span for right around 250 grand. So it was still a pretty expensive project, but it was 25% of the cost of the original design that they were taking a look at. We have done the engineering on a couple of spans up over 2,000 feet. We haven't had anybody kind of, pull the trigger on those, but we know that from an engineering perspective, we can actually do that. Outside of heavily treed areas, substation exits are probably our most common application for spacer cable. And again, it just comes from getting more in a much tighter space on the poles themselves. And that's, you look at heavily treed areas, and we always had clients look at, you got to look at life cycle costs, over the next 30 years, and how much are you going to spend on tree trimming and maintaining this line. With a lot of these other applications, and substation exits are a perfect example of that. Spacer cable can actually save you money, up front. So you start seeing the benefits of it, right away. This is a good example of, 8 circuits coming out of a substation. This particular installation, the transmission came in on one side, and out the back where they were going to have the distribution circuits, they only had 15 or 20 feet between the fence line and the property line. So they had to get 8 circuits out of there. So they used covered conductor spacer cable. It came out really just 2 poles, turned a couple of 90-degree angles, and then went right back out to the road. So this one, you can see that they've even got, the actual exits, coming out of the sub that are overhead. But if you look closely in the picture of the right, it's all covered conductor that goes through the dead end grips and connects right up to the bus work, and everything's covered. So it's still a very reliable system. Everything is covered. This was from it's an investor-owned utility in northern Indiana. But I always see a lot of these types of substations at co-ops. You know, you've got the transmission right away coming in along the railroad or along the highway, goes in and out of a substation. And if you look at the picture on the right, the substation exits, there's 2 circuits, and we're using the same poles, the transmission poles, as underbuild for the spacer cable. And those are pretty long spans. But again, we'll just design the messenger to meet those, you know, 350-foot spans that the transmission poles are at. So you don't need those intermediate poles or the distribution only poles for those longer spans. This one is a power plant in southern Indiana, right along the Ohio River. This shows structures that have 8 circuits on them. You know, we're not going to see this too much outside of, you know, an industrial or generation. But I do have one customer in northern Indiana that actually came up with a design to put 12 sets of cable on one set of poles. Obviously, these are, you know, express circuits. So there's no taps or anything like that, but again, much lower cost option than you know, doing this stuff with underground or even bare wire. So this just this is a dimension drawing that we've got that gives you a little bit of an idea of how much space on the pole it takes up and the clearance requirements. On the left, we've got a 15 kV circuit. On the right, we list that as a 25 kV circuit, but these same spacers are actually good all the way up to 46 kV. So the same dimensions would apply. So it's not too much to say you could probably get, you know, 4 circuits at 25 kV or even 35 kV on a 45-foot pole without too much trouble. Wildlife protection, we do have a couple utilities out west that have really kind of targeted some specific areas for where they want to focus on wildlife protection. Most utilities are looking at devices that will protect against either electrocution or collisions. The nice thing about spacer cable is one of the few solutions that actually protects against both of that. So obviously it's a covered system. Even when we make a tap like we show in the middle, you can see they've exposed one of the phases to come down to a single phase transformer. But in those spots, that's where we recommend you cover up the messenger. So 3 of the 4 wires are always going to be covered. So if a squirrel or a raccoon or some bird gets up into that, they can even stand on that exposed part and they're still not going to get electrocuted. By the same token, because it's a kind of a bundled system, you know, the conductors are all, you know, bundled together, and we've got a spacer that's every 30 feet. It's a pretty good visual deterrent as well. I already touched on this a little bit, but one of the more lesser known benefits of using spacer cable is actually a reduction in voltage drop. You see about a 20% improvement or reduction in voltage drop just by using spacer cable. So if you've got an installation where maybe it's a good size load and it's quite a ways away from a substation and voltage drop is a concern, you know, we can help you do the calculations to see if spacer cable might be a way to save you from having to build transmission line and a substation just to feed, you know, a relatively smaller, you know, remote load. Underbuilds, I already touched on this a little bit as well. If there's enough capacity available on the existing poles, this is a great way to use existing infrastructure to get some distribution or even some more transmission circuits installed. You know, express circuits, anything, you know, tie circuits between substations. We've even have some clients that'll use existing poles for overbuilds if you're going to build a tie circuit between substations, or, you know, if you've got like a 35 or a 69 kV and you call it a sub-transmission system between your substations. If there's enough, again, you have to have enough capacity on the pole, but you can, you know, lower the existing distribution down, stringing the spacer cable above it. And again, it'll save you a lot of money and labor from installing, replacing a bunch of poles. Like I said, here we go all the way up to 69 kV. Here's some of our 69 kV pictures. Again, same basic concept, messenger supported system. It's just the thickness of the covering's bigger, as well as the spacers themselves. Single phase, we've seen quite a increase in our single phase spacer cable usage. In years past, that was always kind of the the last place that utilities were going to put a lot of money and maintenance and resources. But sometimes some of these more remote areas, some of these more difficult to get to areas, they have the most issues with. So a lot of utilities are looking at, well, let's build it with spacer cable now. We'll build it very robust up front, and then we don't have to worry about putting so much money into maintenance down the road a ways. They can focus their O&M dollars on their three-phase main feeders and industrial customers. But even just these kind of steep slope mountain type applications, it's a good spot for cover conductor. We really shine because of how strong the system is in areas that pick up a lot of ice and wind. We tend to get a lot of these pictures after significant ice storms. We always tend to find, an engineer with a company that's going to start using spacer cable as kind of a new construction type for them. And they're kind of sticking their neck out and saying, I think this would be good for us to use. So when they have a big storm or something that comes through and it performs the way it's supposed to, they're always proud to send us pictures of damage and stuff. This is the photo that I always use when people ask me, how does it do with the cold weather? This is actually Hendrix spacer cable used at McMurdo Bay, the weather station in Antarctica. I always say this is a nice summertime picture in Antarctica, and the only reason I can tell that is because there's actually people outdoors instead of inside, because I don't think you can leave the buildings during wintertime. Banff National Park, a lot of federal projects where they want to minimize tree clearing and tree trimming. Look at using spacer cable. This one, a lot of the reason was these areas up here in this national park up in Canada are really, really difficult to access, a good 6 or 8 months out of the year because of the amount of snow that they get. So every spring and fall, they patrol all their spacer cable. And this was one of the first years that they did it. You can see there's 3 trees laying on this particular span, still up in the air, still energized. They just had to, go ahead and remove those trees. Steep inclines, mountainsides, any difficult place to get to. We've even done a couple of mining installations where there's been, close to a 45-degree slope going down inside of a mine. And we've got some different installation practices for doing that. Contaminated or coastal areas, we'll always kind of look at not only the level of contamination there, but the amount of annual rainfall. The polyethylene that's used in our insulators and our spacers and the covering of the conductor washes very well, but we require, it requires a certain amount of annual rainfall. So we want to make sure we're meeting that. But we've also got the option of, over insulating either the cable or the spacers or the insulators or both to meet whatever requirements are required. Areas demanding high reliability. You talk to most utilities and that's almost their entire system, but you kind of look at, commercial and industrial, food manufacturing, transmission lines, critical customers, hospitals, things like that. Any place that may require, a second separate circuit feed, Not only is this a reliable system, obviously, but it's a good way to get that separate circuit in, maybe on a set of existing poles, without too much repair or replacement cost. Renewables, we've done a lot of wind farm projects where they're using spacer cable for the collector circuits. This is probably the biggest spacer cable installation in at least the U.S. At least I think it used to be. This is 550 megawatts, so this is 11 circuits, 50 megawatts per circuit. So this is all 35 kV. I believe it's a combination of either 1033 or 945 kc mel conductor. So pretty good sized conductor. A couple of the different things they looked at for this, obviously, using covered conductor in this configuration kept the height of the poles relatively low, so that minimized the shadowing on the solar panels. But obviously this is out in the middle of the desert, so the benefits from the voltage drop or a reduction in the voltage drop was a big benefit to this project as well. But just getting that much capacity in such a small space on these poles, I'm really not sure how else you would be able to do it. We won't spend a lot of time on this. This is actually going to be the topic of one of our upcoming webinars. Some of the kind of common myths and misconceptions about spacer cable. And a lot of this comes down to the right tools and training. And we always try to emphasize, life cycle support from Hendrix. When your name is associated with product the way that Hendrix is with spacer cable, we want to make sure that it maintains a good relationship or a good reputation in the industry. So, and again, we've been around for, 60 going on 70 years. So, we kind of get the same, basic questions, especially from, operational folks. And, that the cable is difficult to strip. It usually comes down to having the right stripping tools that are designed specifically for spacer cable, how to make taps, grounding the conductor, work clearances, and all that other stuff. And we've got the ability to do the training either remotely or on site. We've got field service guys that literally travel all over the world helping clients install spacer cable, because it is a little bit different than installing traditional bare wire. But we also, provide training classes on operation and maintenance. Conductors, when they come down, and restoration. And again, that's going to be the topic of another webinar we've got coming up. But we also do full engineering and design support. We can do anything. We've got clients that will just send us a list of parts for an existing project or a new project that they've designed, and we can give them a price just on the material. We can do, they design it in-house and we do a design review, or we can do all the way up to more of a turnkey, type of situation where, they're giving us point A to point B, and what do we need to do to convert that to spacer cable or to build a new spacer cable line, and we can do that full design. So, just a full amount of support. One of the other tools that we've got available to our field sales folks is what we call our value calculator. And there's a couple of different versions of this, but this will kind of compare aerial spacer cable to bare wire or to tree wire or even underground, and give you, some of the cost savings that you would see with regards to labor, what the cost of those outages are, even the upfront cost and how much, that would differ between, those different installations depending on, what application is. The nice thing about these is, we make some assumptions on labor costs and things like that, but if a utility knows what their specific costs are, it's all completely configurable. So we can use your specific POS and change those numbers up and give you a lot more of an accurate estimate of what kind of savings and benefits you might see. And really just, kind of build a business case for cover conductor and spacer cable use. As Dave mentioned in the beginning intro, we do have more of these webinars coming up, and this will just kind of give you the next one. Like I said, we're going to do a more of an in-depth comparison of spacer cable versus tree wire versus bare conductors, obviously focusing on the overhead portion. We do have an installation one that'll be more operationally focused, as well as some restoration and safety discussions coming up. So, we tend to, as a company, we'll spend a lot of time, selling spacer cable to management and engineering folks, and that's kind of, what the focus was today. But the reality is the guys that are working on it on a day-to-day basis or installing it really, need the training and need the education as much, if not more, as well. So we're trying to do a little bit more of that type of training with this series of webinars this year. We do have some CUE credits available for folks that are looking for that. And there's an email address, and we'll follow up with you after the end of the webinar. The other thing that we're always asking clients for is if there's ideas of presentations or more training that we can provide on these webinars, please let us know. We don't want to, we want this to be as beneficial as possible. Again, the right tools and the right training for our clients is kind of the key to success for us, moving forward. We want to make sure that it maintains the good reputation that it has, and we're providing people with the tools and the information that they need. So you'll see a survey that'll come out once the webinar is over, and I encourage you to fill out that survey. If there's something more specific that you'd like to see from us, reach out to Dave Shockley. He's our sales director, and he's laying out, I think another series of these even in the fall. So again, we just want to make sure we're giving everybody the information that they need. I ran about 10 minutes past my time, but we still have plenty of time for questions. So, Dave, do we have anything?
All right, thank you, Ted. Yeah, we do. We have several questions, Ted. Thank you. Very good job there. I'm going to try to get to most of the questions. If we do not answer your questions, we will provide an answer in writing and share it with everybody that's registered on this seminar. And Ted, you can answer these. I've also got Brian Traeger where he's allowed to speak. So if you want to default to Brian on some of these, I'll leave that up to you. So the first one is a simple one. What's the length of the tangent brackets?
We've got two different tangent brackets available. Our standard 15 kV is we call it a BM14. Our engineers traditionally haven't gotten overly creative, so it's a 14-inch bracket. For 25 all the way up to 35 kV systems, we recommend our BM24, which is, as you guessed it, 24 inches long. We do have clients that will use the longer tangent brackets, even at 15 kV, if they want a little more clearance between the pole and where the phase conductors are. I had a client a couple years ago that said, that told me on multiple circuits where they've got two circuits back to back, they like to use the longer tangent brackets because that gives them, their linemen, enough clearance to work on one phase or one circuit, so they don't have to cover up the other circuit because of the length of the tangent brackets. But kind of the standard is our 14-inch bracket for 15 kV systems and our 24 inch bracket for 25 all the way up to, I think I said 35 kV, but that's actually good all the way up to 46 kV.
Okay. Next question is, how sensitive is the useful life to partial discharges produced by a tree branch making permanent contact with spacer cable? So if you got a tree branch laying on it, how does that affect the useful life?
That's a pretty difficult question to answer. Our recommendation is, we don't want, since it's not fully insulated cable, we don't want trees coming in contact with it all of the time. So, our rule of thumb is, you want to trim the trees back. They can brush up against it, they can fall on it, and that's fine. We just don't want them to come in contact with it all the time. Now, if a tree limb lays on it or, comes down and is laying in the spacer cable, there's a lot of different variables as to how long that'll last before it'll fault. So what we commonly recommend is after a storm event or something like that, or maybe on a regular basis, clients will go out and patrol their spacer cable. I've had, tree branches laying in spacer cable for over a year, and before it actually causes a fault. There's been, studies done at different voltages and different types of trees, and because some species have more, moisture to them and all that other stuff. But it really kind of depends. I think our official line on the useful life of covered conductor spacer cable is 30 years. But, obviously that can be shortened by, a lot of tree contact or a lot of, incidents of trees and tree limbs falling on it. So, 30 years is right around the number when, we tell clients maybe they want to think about, swapping it out or replacing it.
Okay. We had a question about the 115 system. What is the top ampacity rating for that? I will tell you that I talked to Brian during the chat, and it looks like it's a 1033 mil cable. That is the largest cable that can fit in the 115 system. And at 90 degrees, that will allow you 983 amps. So it looks like it's around 980 amps as the top ampacity on the 115. So I answered that one for you, Ted. See here, can you talk about some of the lightning protection requirements for spacer cable and the lightning, the benefits for using spacer cable in the high lightning prone areas?
Well, what our normal recommendation is with regards to lightning arresters is the rule of thumb is any place that you've removed the covering, we recommend you install lightning arresters. Now, obviously, you're going to remove the covering for equipment taps for transformers. So there's already there's already an arrestor there to protect the equipment. Where we don't tend to see them as much as we'd like to is for taps. But a lot of utilities you're seeing more, if there's a single phase or a three-phase lateral tap, they'll hang a cutout in a set of arresters there. So that's what we like. The other places, even on transition points where you've got covered conductor on one side of the pole and bare conductor on the other, we like to see a set of lightning arresters there. With regards to the messenger, again, our recommendation is we don't want clients to go any more than 500 feet without grounding the messenger. Most utilities that I've worked with in the past ground it at every pole. So it becomes a pretty well, lightning protected system, believe it or not. So obviously a good chunk of our spacer cable is used in heavily treed areas. Lightning may hit an adjacent tree and some of that surge might transfer to the messenger. The downside to covered conductor is, pinholes that are made by lightning or other surges are difficult to find. Fortunately, it just doesn't happen, very often. So I always try to kind of take a more of more of a take a step back look at, what caused, lightning may be traveling down the messenger and it's looking for a deterioration in the covering. So I try to say, well, what caused that deterioration? Was it due, was it man-made? Was it due to, removing the covering to make a tap? Well, there's already no light on the arrestor there. And then it kind of refers to the initial question of, if you get a lot of tree rub and it's caused deterioration in the covering, that's another, potential opportunity for a flashover. The thing with polyethylene is it has a relatively high melt temperature. So you don't see a big spot where it's going to melt and burn back, like maybe like what you'd see with underground cable. We don't have a lot of voltage stress there. There's not a ground nearby that's going to cause a lot of arcing over a longer period of time and cause like a big, glob of hot molten aluminum and everything melting together. It's going to be a relatively small spot. So it can be difficult to find, but like I said, fortunately, it just really doesn't happen, very often.
Ted, what about the construction aspect of spacer cable, having a messenger as a neutral and acting as a static wire? Can you we have a white paper on this as well, but if you'd like to go, more in-depth reading, we can send that to you, but maybe you can address that as well. Someone asked that question.
Yeah, I mean, and that's kind of, that's something that we've thrown out in the past since a neutral and it's grounded is on top of the system. It can really work, just like a static wire, like you'd see with transmission. But again, the incidents of that are so small because of the, just the environment where spacer cable it tends to be used. Now, if you saw some of the, if you notice some of the pictures where, you get into some of these steep slopes or these mountain type installations, or, out in the desert where it's a, for, renewable installations, solar farms, wide open spaces, and then you've got these ductile iron poles or these steel poles. That's where it really, it becomes imperative that it's properly grounded, and the resistance is kept relatively low. So, it'll work just like a static wire. I seem to recall maybe even having some clients that'll string in spots like that where there isn't anything, maybe even a separate static wire on top of those poles that's grounded as well. Just another layer of protection.
Okay. We had a couple questions about the voltage drop, how spacer cable actually helps with the voltage drop. You mentioned up to a 20% reduction. Can you explain that a little more in depth?
Yeah, I mean, when you go through and you're calculating voltage drop, one of the key, components of that calculation is the distance between the phases, the gross, the geometric mean distance. So since it's covered and we can put it relatively close together, that reduces that number. And if you work your way through the calculations, it'll actually reduce the impedance of the circuit because the phases are that close together. So, and we see it, like I said, and I kind of, scrolled through it relatively quick, but that's another paper that we've got available and we'd be happy to send out. But you see about a 20% improvement in voltage drop for the same size conductor, just a spacer cable configuration versus in bare wire.
All right. I'm sure I didn't miss anything else, Ted, but I think that's most of the questions. If we didn't get your question answered, we will definitely respond. We go through the questions and we respond to some of these more technical questions with emails, either from Ted or Brian Traeger. We did have a question here as far regarding long spans, Ted. Does on a long span, does it reduce the diameter of the cable? And, does it, do you have to go to a smaller cable just because you're going to long span?
No. Like I said, the main mechanical component of a spacer cable system is the messenger. That's the support member. The phase conductors, it's all 30-foot spans. So, if you looked really close in one of the pictures that I showed, you'll see, they doubled up on the spacers. And that picture is just taken from a particular utility that's just their standard. Anytime that they're going over a roadway of any size, they double up on the spacers. It's really not required. If y'all want to buy more spacers, that's fine with us, but it's really not needed. But from a sag and tension perspective on the phases, it's all 30-foot spans. So, it's very distributed weight. It's under very low tension. So we don't have to, we don't necessarily, worry about the size of the conductor depending on the span length. Again, it's all 30-foot spans. Now, we realize the fact that there's more surface area on the phase conductor, so it will pick up more ice and there's more wind loading, but we take all of that into consideration when we're doing our engineering calculations, and that's really only going to affect the size and the tension that's on the messenger.
Okay, we have one about cable stripping options. Is there an option to strip it with a hot stick if they have to work everything off of energized off a hot stick?
Yes. There's mainly two different stripping tools that we recommend. One is made by a company by the name of Ripley, and it is a fixed stripping tool. So it only works on one size cable. It's got kind of a clamshell design, if you will, that's spring loaded. So you can open it up and lock it into place, put it on the end of a stick and clamp it on the cable, and then you start spinning it with the stick and it will strip the cable. The other one, so that's the advantage of that one. The disadvantage is you got to have one for every size conductor that you have. The other one is a Speed Systems adjustable tool, which makes it really flexible from a perspective that obviously it's adjustable. The downside to that is you need, you got to put your hands on it to do it. Speed Systems, I want to say a couple of years ago, developed a hot stick operable adjustable stripping tool. I've heard good and bad things about it. I think they're still kind of fine tuning the design, but that'll be about as close as I've seen to, kind of a good, one size fits all type of a stripping tool. When you go to those companies, what you're really looking for is these devices are called mid-span stripping tools. When you're doing an end cut to make, a connection to a bare wire tap or something like that, you can use your underground tools because, it's an end cut. So those will work just fine. But when you're making a tap, mid-span, you want a mid-span specific stripping tool. So, those are, and we'll cover, that'll be part of I think we'll probably touch on it during the installation webinar, but definitely on the restoration and maintenance one that we'll be doing. We'll talk a little bit more specific about it, but that's the quick Reader's Digest version.
That's a good point. That will be covered in the other seminars. Just a quick question, Ted, is there any preferred method of covering our taps, gel wraps, tape, or do you even need to cover them?
This is we get this question quite a bit. Kind of my personal stance that I take on it. I think in the past, we've recommended you cover up the taps. The problem is we've never really given you a good way to do it. And if you look at most of our standard drawings and some of our literature, we always show them as being exposed. I've got utilities that leave them open. I've got utilities that will tape them up or use some type of gel, cover or something over top of it. You're not hurting anything by covering up the taps. What our recommendation is, every 24 inches, you want 3 of the 4 wires covered. So if you expose one of the phase conductors, we recommend you cover up the messenger. And then you'll spread out the taps on the phases by 24 inches along the line. It's kind of hard for me to describe over the phone, but so that's for taps. From my perspective, I like to leave them open. I like to see them open. Number one, you can see the actual connection. If you ever have to work on, that particular section of the circuit and you need to ground it, you want to see that visible break. You want to see, where that bare aluminum is, if you need to take a tap off and put a ground on it. Because, that's what our recommendation is. You can't ground the conductor over top of the covering. So typically you can find a spot that's been exposed, for a tap or whatever. If that's covered up or taped up, that creates, some issues. So I like to see them open, but we can still spread those out so that, again, 3 of the 4 wires are always covered up. But again, if you want to go ahead and tape that up or what have you, you're not going to hurt anything. The misconception is that we need to cover that up to see, when I hear people say, well, I was taught that I need to seal up that tap. To me, that is indicative of somebody that's taking what they've been taught about underground cable and applying it to this because they're both covered. This is not insulated cable. There isn't a ground shield on the outside of it like you'd have with underground. We use compact conductor that's overhead. It's incredibly difficult for moisture to get inside the covering of the conductor. If it does, it's all aluminum conductor. It's really not going to hurt anything. There's no steel component to it to, deteriorate or corrode. But it's also compact, so there's really no airspace in there for moisture to get. With underground, you're kind of taking like a wet sponge and you're putting it on the cable and you're almost forcing water into it. And obviously, because it's insulated cable and you've got a ground shield on the outside, it's always trying to work its way through that insulation, and that'll cause failure. So yeah, absolutely. That's one of the most important things about dealing with underground cable. You got to seal it up. You got to keep the moisture out of it. We're not necessarily worried about that with overhead cable.
Okay, great. Probably one of the last questions is capacitance a concern with long distances?
The quick answer to that is no. Brian, I'll defer to you. What?
Yeah, Ted, hi, I'm here. Yeah, I'm here. So we've had some questions recently, and I apologize that I forget who submitted them. So, when we switch underground circuits, what you do is you release a long landline capacitor into that transformer, and you may or may not have what's known as ferroresonance, so that the capacitance is equal to the inductance of the rest of the system. And then you have a resonant system condition. You have voltage waves going back and forth and over voltages and possible, blowing up some equipment. That condition does not occur in a covered conductor situation because there is no long landline capacitor. There is no concentric neutral to store that energy that will be discharged upon opening that switch. So no, that is not an issue as far as that cable being a long landline capacitor and having it discharge. If there are longer questions on that, or I fumbled through that explanation, please write us or write that Mr. Shockley, Dave Shockley at marmonutility.com, and we will give you an intelligent written answer on that. Thank you, Ted.
Yeah, we had one question asking if the messenger can house a fiber optic, just like an OPGW cable. I'm not sure if that's still an option. Michael, that answered that. I'll have to get back with you to that, unless you know, Ted, something I don't know, but I'm not sure. We've done it before in the past. I'm not sure if it's still.
Yes. Yeah, we've, it's kind of a tricky question, a tricky response. We don't manufacture OPGW. But, and if you reach out to the manufacturers that do, a lot of them will say, we don't recommend you use it to support the weight of spacer cable. That being said, we've done a handful of projects from little tiny municipalities that will have a spacer cable circuit, you know, running from a substation to near their service center. And they use that for communications, to that large desert solar ranch in Southern California that uses OPGW. We've done the calculations. We've got the field experience that we're confident that it functions very, very well, and it saves a lot of room on pole. So, you know, there's a couple of different, obviously, ways to do that. You can, you know, embed it in the messenger. We've also looked at in the past of having kind of almost an add-on to our spacer that will support a separate fiber optic, you know, piece of fiber optic, but I'm not sure where that project is at. But yes, in the past, we've used OPGW with the spacer cable system, and it's been a good solution. We're happy to work with another manufacturer for that messenger, because obviously we can get it, but we don't manufacture it in-house.
Yeah, and if I could add to that, Ted, one of the arguments from the fiber manufacturers as well, you know, I'm not sure if you're going to hang a massively heavy system on there and bend the tube and damage the fiber and prevent the light from getting through. In reality, we've installed thousands of miles with OPMW, optical messenger wire, with the fiber in that messenger, with 35 kV, and I mean shockingly heavy conductors, 795, 954, 1033, 1272, 1351, and we have never had a problem. So that's one thing on the 35 kV, really heavy stuff. As far as 15 and 25 kV, we've used OPMW in the country of Brazil for, I want to say, 25 years. So this is not new technology. Yes, you can do it. What Ted was referring to is that, unfortunately, we don't sell a messenger with a fiber in it. So that's, you know, we can work with the people who do sell it.
Okay. I think that's the last question I see here, unless someone has another one. But I did have a question from a couple people. If we're able to share this presentation for reference in the future, we can do that. We have your information when you register for the seminar, so we can make sure you get a copy of this. You also get a link. I think Ted mentioned this. You'll get a link to the recording of this. So if you want to review it, watch it again, or share it with your colleagues, feel free. You will get an email at the end of this. Just a reminder of the other seminars there. Ted has it on the screen. We have the next one. I think Brian will be presenting this, which is spacer cable versus tree wire and bare conductor circuits. And then something for the operational folks, spacer cable installation, and then restoration and safety. So those two are fairly new subjects for us and when it comes to webinars. So I would encourage you to tune in on those. The other thing I would encourage you to do, if you are looking for your local rep, we have rep partners throughout the United States and some parts of the world. If you want to know who your local Hendrix person is, go to our website, and that's marmonutility.com. And you can search by state and by product line as well. So we encourage you to do that. So if you think of a question later, either reach out to Dave Shockley or go to the website and either submit it through the website or submit it to your local rep. Ted, do you have anything else to add?
No, I think everybody's going to get a survey after this, and I encourage everybody to be as honest on that survey as possible. And like I said before, if there are topics of interest with regards to covered conductor, spacer cable, tree wire, what have you, that would be of value to you. Most likely it would be valuable to a lot of people. So by all means, submit that to Dave. We're always looking for feedback and recommendations for future topics that we can cover. That's of great importance to us. We want to make sure we're providing, like I said, the right training, the right information that's of most value to our clients. So, okay.
If no other questions, and Ted, you don't have any, I'll go ahead and end this session. We really do appreciate each and every one of you taking time to join us today, and look forward to seeing you on other seminars. So have a great rest of your day. Thank you.